like the computer's over here, so I kind of gotta like.
Key part of it.
Alright, let's go.
Alright, hello everyone. So our toy is the Boilermaker Super Special. I'm Aaron.
I'm Taka.
And I'm Josh.
Alright, so to begin, I think we're going to give a little bit of background on the inspiration for our toy. So as you may be familiar with from past experiences or presentations about an hour ago, the useless box toy is kind of the concept of you hit a switch and some sort of mechanism comes off out of it to turn the switch off. And while on the surface that might not sound like the most interesting thing in the world, there's a lot of ways to code some sort of excitement into the program, such as more delays in the mechanisms, adding additional ways of turning the switch off, or a couple other fun surprises that we're going to get to in a minute here. So beyond the original useless box concept, one of the important design requirements for us was to incorporate the Purdue theme with the 150-year anniversary coming up. So in light of that, we decided to model our useless box after our school mascot, the Boilermaker Special. I know from experience when it's broken down, we've called it useless before, so useless box, Boilermaker Special kind of came together into our toy. For our target audience, we believe, in terms of children that might be interested, in the age range of 2 to 8, the younger end being just because it's a larger toy, so kind of less like a risk in that regard. But also, really anyone can appreciate the humor behind trying to flip the switch on and having something come out to turn that off. In addition to that, any Purdue fan, train enthusiast, or just anyone who likes kind of a fun toy to mess with their friends might be interested in this toy as well.
So now I'll be talking about the key features of our toy. So our toy, essentially in its most basic form, is flip the switch, and then there's a servo that will bring the hammer out of the back and flip the switch back off. But incorporated with that, we have an ultrasonic sensor on top to sense your hand coming in, and we have 2 DC motors inside. And so the DC motors will drive the car away, reverse the car, or possibly even spin the car. Well, train, I guess. Train. And on top of that, we have yet to implement the LED lights. We have the holes drilled out and they're all wired in, but we just haven't gotten around to getting the code working for them yet. But there'll be the front lights and the rear lights for reversing and driving away. And we, our hammer, there's multiple speed, theoretically there are multiple different ways our hammer works right now. There's the fast hit, slow, and then there's one where it just the one that it's currently stuck on, where it just comes up and down a whole bunch and then eventually hits it. And then we also have a tail rear that has been printed, but we just didn't have time to attach the hinges because we were trying to work on our code. But the back door opens and the hammer comes up, hits the switch. So, oh wait, wait no. So yeah, our mechanisms are essentially the motors inside and the servo on the back. We can try and give you a demonstration right now, but it may or may not work, so we'll see.
You might need to unplug it. Put the battery first.
Yeah. All right. So. All right. Yeah, this is what I mean by the craziness. Oh, there we go. So then it switches it off, and we have 6 other settings currently programmed, and we're working on getting a few more, and hopefully we can, we'll have it done by Monday, but hopefully we can figure out what's wrong with our motors.
And moving on to prototyping. There you go. Okay. So we first created a 3D model using Creo. We have yet to have a video that shows the working mechanisms, but we'll have that by Monday, as Josh mentioned. And then when it comes to the actual modeling of the train, for the base plate we used laser cutting, and also for the train body we used SLA printing. And for the rest of the body, for example, the smokestack or the piston or the back piece, those are all printed using the Volspot 3D printer. And then in terms of the wiring, again, there are 2 DC motors in the front that actuates the wheels, and then there's also the servo motor that actuates the hammer, as well as the Hall effect sensors that can detect the human hand motion. So, and what we have up here is if we were to mass manufacture this product, we would likely use injection molding for the train body, the hammer, and the train tail. And then for the train base, we would likely use some sort of stamping process. And circuitry will just be with PCB. And then with actually assembling the pieces together, when it comes to the electronic components, we'll be using soldering and just securing the pieces onto the base plate, as well as screwing the train body as well as the train tail onto the base plate. So
Most of our current wiring is pretty, it's not permanent. We have like a breadboard and we use hot glue to secure some wires just because like the soldering and like the connection pins on LEDs doesn't really work very well. So we just use like hot glue to secure them in place. So yeah, if we were to make it more permanent, we would solder our connections and hopefully it would work a little bit better. You guys got any questions?